Thanks for watching my video. Today we are going to discuss an infinite series proposed by Srinivasa Ramanujan, which is a famous Indian mathematician, and this was a problem submitted to the Journal of Indian Mathematical Society around 1911 and 1919. Okay, so this was Ramanujan question. Okay, so how did he manage to solve this one? So we are going to discuss here. So first of all, in this sum, this one, okay, 1 over 4n keep minus 4n. So we are going to split this first. Okay, so now let us split. Okay, now in this, so we are going to split and we are going to use partial fraction. Okay, so in this, so let us take 4n common. So here 4n square minus 1 same as 1 square, so which is 1 over 4n plus 1 4n minus 1. So okay, so this is the splitting term. Now we are going to use our partial fraction. Okay, therefore let me show the partial fraction part. Okay, so 1 over 4n cube minus 4n is equal to a over 4n plus b over 4n plus 1 plus c over 4n minus 1. Okay, now we are going to find out a, b, c. So then us cross multiply it. So 1 equal to this one transfer here. Okay, so you get 16n square minus 1 plus b 16n square plus 4n plus c 16n square plus 4n. Okay, because this one transfer here and this we can cancel this two and this two will multiply it and just okay. So in this, now let us separate a, b, c. Okay, okay, now we are going to arrange the term as n square n and n to the power 0. Okay, now this is in this there is no n square or n. Okay, in the left hand side, meaning this term must be a constant, right? So therefore 1 is equal to negative a, meaning a is going to be negative 1. Okay, and now what about let's find out a plus b plus c, which is equal to, here n square is not here, so that's why it will be 0, right? Now we know that a is negative 1, right? So minus 1 plus b plus c, which is equal to 0, meaning b plus c must be 1. And sorry, in this b minus c, in this b minus c, there's no n term here. Okay, right, and there's no n here, so that's why this will be 0, meaning b is going to be equal to c. Now if I put b equal to c here, b plus b must be equal to 1, meaning 2b is equal to 1, so b is equal to 1 by 2. Therefore c is equal to 1 by 2. This is what we are going to find out. Okay, this is our required here. Now if I plug here, okay, now therefore 1 over 4n cube minus 4n is equal to 1 is a, a here, a is negative, right? So negative 1 over 4n plus 1 is b, b is 1/2, right? 1 by 2, so if you plug here 1 by 2, meaning 1 by 2 by 4n plus 1 plus c is also 1 by 2, so 4n minus 1, right? Or in this, if I take 1 by 2 common, meaning half, if I take half common, you will get n plus 1 plus right. So if I take half common in here, so I will get this one. So in this part of summation here, this one, if you use partial fraction, and we get this one, right? Now we are going to sum up, right? So let me sum up. Yes, the sum goes from 1 to infinity of 1 over 4n cube minus 4n, which is equal to half. I'm going to take it outside, okay? And the sum from n equal to 1 to infinity 1 over 4n plus 1 plus 1 over 4n minus 1 minus 1 over 2n. Okay. Now adding and subtracting 1 over 4n plus 2. Now in this here, I'm going to add 1 over 4n plus 2n. I'm going to minus again, right? In order to get this one again. So let me try in the next page. Therefore, sum from n equal to 1 to infinity 1 over 4n whole cube minus 4n. Okay, which is equal to 1/2 the sum from n equal to infinity. So 1/2 the sum from n equal to 1 to infinity of 1 over 4n minus 1. Okay, let me write first this one. Okay, 4n minus 1 minus 1 over 4n plus 1 over 4n plus 1 minus 1 over 4n plus 2 minus 1 over 4n plus 1 over 4n plus 2. Okay, these two can get cancelled, right? So you will get the same result in this one. Okay, remember that here this one 1 over 4n and 1 over 4n, this one, these two come up from here. Okay, this one minus 1 over 2n is same as minus 1 over 2n. I can write in as minus 1 over 4n minus 1 over 4n, because this 2 is plus 2 over 4n, so this is minus 1 over 2n, right? So that's why in place of minus 1 over 2n, I just put this one. Okay, 1 over minus 1 over 4n and minus 1 over 4n. Okay, same thing. Now I'm going to arrange it now. Okay, which is equal to, let me call our sum to be s. Okay, this one now, which is half the sum from n equal to 1 to infinity 1 over 4n minus 1 minus 1 over 4n plus 1 over 4n plus 1 minus 1 over 4n plus 2. So I'm going to take this as 1. Okay, meaning this one, this and this, right? So this one and minus these two, I'm going to tie it together, okay? So 1 over 2, here 2 can be common again, right? So which is n equal to 1 to infinity, and minus is common, okay? 1 over, how much this will be? 2n, right? Minus 1 over 2n plus 1, right? So this 2 is same as this one, okay? Now we are going to split this one, okay, in term by term. I'm going to break out this summation, okay, and this also I'm going to see what we can get here. Therefore, the sum from n equal to 1 to infinity 1 over 4n minus 1 minus 1 over 4n plus 1 over 4n plus 1 minus 1 over 4n plus 2. This is same as now if I plug n, okay, n here, so I will get 1 over 3 minus 1 over 4 plus 1 over 5 minus 1 over 6 plus and so on, right? If you plug n, okay, n here, and you split up this one, this summation will be this one, and from the expansion of natural log, okay, from the expansion of natural log of 1 plus x, x minus x squared by 2 plus x cubed by 3 minus x4 by 4 plus and so on. Now if I put x equal to just 1, so this will be natural log of 2, which is equal to 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus, and next will be 1 over 5 minus 1 over 6 and so on, right? So our sum, this is going to be what? If you compare these two here, it is same, right? So therefore the sum from n equal to 1 to infinity 1 over 4n minus 1 minus 1 over 4n plus 1 over 4n plus 1 minus 1 over 4n plus 2. This is going to be this one, right? So this one start from here, right? This term, meaning this 2 will be going here. So meaning natural log of 2 minus half, right? 1 minus half is half, so half transfer here, so become minus, right? And again the sum next one, okay, this one, the sum this one, if I plug n equal to 1 here, what do we get? Therefore the sum from n equal to 1 to infinity of 1 over 2n minus 1 over 2n plus 1. Now if I plug n equal to 1 in this 2, okay, so we will get 1 over 2 minus 1 over 3 plus 1 over 4 minus 1 over 5 and so on. So this is nothing but 1 minus natural log of 2, right? If you see here, if you compare this sum and this sum, so minus is taking out right here, minus will be here, so this will be minus, so coming out here, so 1 minus natural log of 2. This root term is same as this one, right? Just changing the sign only, right? So now all sum s is going to be what? Let's see. Now our s is equal to 1/2 into, in place of this one, we get what? What do we get? We get here, right? Natural log of 2 minus 1 by 2 minus, and this one minus 1 over 4 minus 1 over 4 into this one. This sum is what? Same as this one, right? So this is 1 minus natural log of 2. Okay, now simplify this one. Then you will get 3 by 2 natural log of 2 minus 1 into half. Okay, if you simplify this one, you will get this. Okay, now this one, yes, these two transfer here and all this, and simplify one more again, then meaning 2 times the sum from n equal to 1 to infinity of 1 over 4n cube minus 4n, 2 transfer here, okay, which is equal to 3 by 2 natural log of 2 minus 1, right? Therefore, now this one transfer here, okay, therefore you will get 1 plus 2 times the sum from n equal to 1 to infinity 1 over 4n cube minus 4n, which is equal to 3 by 2 natural log of 2. So this is the proof. Okay, so hence proof, and thanks for watching my video.